Welcome. Today we're going to be going over a superelevation problem. This has a 2-lane highway with 12-foot lanes. Design speed is 60 miles per hour. Your E is equal to 6%. Normal crown is 2%, and we're going to assume that there is no vertical curve throughout this whole superelevation. We're going to need to go ahead and find the PC and PT stations and elevations at centerline and edge of pavement, station and elevation at beginning and ending of full superelevation, stations that transition beginning and ends, stations that tangent runout begins and ends, station that superelevation runoff begins and ends. Basically what we'll be looking at is this diagram right here, where you have a tangent runoff, your superelevation runoff from your basically the end of tangent runout to the full superelevation. Within that, on both sides, will be the PC station and PT station, which is at the end of your curve. For this problem, it did ask that we have a 75% runoff to be on tangent. Here I have actually written 2/3, but this will actually be 3/4, and then that'll be 1/3 after the PC station elevation. We'll go ahead and have this will be a curve going to the right, and it'll also be, the superelevation will be turned from the center line. Alright, let's go ahead and get started here. So basically what we have to do first is we have to find our tangent for our curve information. And here we've been giving our bearings of the north 02 west and north 48 degrees east, with a radius of 1500 feet and a PI station of 30 plus 00. So here we're going to have our radius equals 1500 feet. Our delta, and we go ahead and subtract our northing 02 west and our northing 48 degrees east, we're going to have a delta in here. So right now it's looking, our curve is sort of looking like this, and our delta is here, and this is going to equal 50 degrees once we subtract those two bearings. Our tangent, we can go ahead and use the tangent equation, which is tangent equals radius times the tangent of delta over 2. So this will equal 1500 times tangent, the delta of 50 degrees, divide that by 2. This will equal 699.4614 feet. We'll also need our degree of curvature, and that formula is degree of curvature equals 5,729.578. Divide that by the radius. So if we write that out, I will put a 7 there. 8. Divide that by the radius, which is 1500 feet. And our degree of curvature equals 3 degrees, 49 minutes, and 11 seconds. So when we go ahead and put this into our TI-89, 5729.578, divide that by a radius of 1500 feet. What we're going to want to do is we're going to want to go ahead and use our catalog and then the degrees, minutes, second. I'll scroll down to that, degrees, minutes, second here. And that'll give us our 3 degrees, 49 seconds, and if we round this up, 10.98 to 11 seconds. That's what we'll be looking for, which is what here. Our length equals our delta divided by our degree of curvature times 100. So that equals 50 degrees over 3 degrees, 49 minutes, 11 seconds times 100. L equals 1308.9969. Alright, so to go ahead and find our PC and our PT here, which is the beginning of curve and the end of curve, or point of curvature and point of tangent, we'll go ahead and put this as our PC equals, we use the delta here. If we look at the original problem, the delta, or the PI here, is at 30 plus 0, 0. PI equals 30 plus 0, 0, or 3,000 feet. And what we need to do is we need to subtract our tangent length from it, and then to get the PT, we're going to use our PC station that we get, and then add the length of the curve. We don't add the tangent to get to the PI. So we do 3,000 minus our tangent length, and so when we do that, we get 2,300.5385. For our PT, we just add this here to our length of curve here, 2,300.5385, plus that by 1308.9969, and that comes out to be 3609.5354. So at the end of our curve here, our PT equals 36 plus 09.54, round that up, and our PC equals 23 plus 00.54. So now that we have those, we can use our equation to get our superelevation runoff and our tangent runoff.